Students, we have done lecture 2 on electrostats. We will be doing the continuation of the electrostats in our lecture 3. Okay. So, what we have done in the last class? We have done in the last class is, first of all, we say it's equilibrium of charges. Yes? This is the topic we have cleared in the last class, equilibrium of charges. And what we have seen, only plus minus plus or minus plus minus. This is the only combination. This is the only combination for the equilibrium. Okay? And no two consecutive charges, no two consecutive charges must have same magnitude. Means two consecutive charges will not have the same magnitude. This is the means either this two or this two, they won't have the same magnitude. Okay? And when I am saying equilibrium, that means net force on each has to be equals to 0. This is the basic. Now, what sort of equilibrium? Yeah, this is the last topic we have not done. Okay, we will be doing it today. Okay, what equilibrium? Now, equilibrium are of three types. Equilibrium are of three types. One is stable equilibrium, another is unstable equilibrium, and another is neutral equilibrium. Now, I will just say something. What is stable equilibrium? Stable equilibrium means if you displace any of the charges, if it return to its own position without affecting any other charges, then we say it is in stable equilibrium. Unstable means if you displace any of the charges and the system is not in its original position, it is unstable. And what is neutral? If you displace the charges, the other two charges won't be affected and the new charge will be placed over there. Okay? So let's check out what sort of equilibrium. Let's say this is plus q and this is plus q, and in between we have a minus q dash. Let us assume that this is in equilibrium. Okay? So what is the value of the q dash? We know already. What is the value? Yes sir, we have heard what we have seen. 1 by 2 extremes, 1 by plus q has to be equals to 1 by q dash. Yes sir, we have seen this thing. This is, so sir, ultimately twice by root q is equals to 1 by q dash. So q dash comes out to q by 4 magnitude wise, and so it is in minus. It's a negative charge. Yeah. Okay. So we have seen, sir, let us assume this is a configuration. This is a configuration. How to say whether this configuration is in stable equilibrium, neutral equilibrium or unstable? Simple. You displace any one of the charges. You displace any one. Suppose if I displace this charge over here. If I displace this charge over here, what happens? What happens? So first of all, this charge will automatically face a net attraction towards this charge. Yes or no? Yes. If I displace a plus q over here, the distance between q and q dash increases and this attraction force will be greater, and so this minus q dash will move to the positive charge. So if you displace any of the charges in this scenario, it will be a neutral equilibrium. So this equilibrium is, not neutral, this is unstable equilibrium. If I displace any of the charges from this either position, they won't return back to its own position, and they will also what? They will also dismantle the position of other charges. Okay, so this is unstable equilibrium. Keep in mind, they all are in one line. They all are in one line. So this was the last topic which we were going to study: the stable equilibrium, unstable equilibrium, and the neutral equilibrium. Okay, now have a note. We will move to the next topic. Now, let us deal with some few basic numericals which actually do come in our school exams and in our competitive exams. Very beautiful numerical. Let me talk about. Say, two charges Q1 and Q2 are placed at a distance d apart. Okay, keeping in mind mod of Q1 is greater than mod of Q2. Fine. Now its next says how much charge needed to be transferred from Q1 to Q2. How much charge must be transferred from Q1 to Q2 so that force between them is maximum? Now this is a very good question. Okay, so when can the force between them is maximum? So simple. You take in this way, it's Q1, it's Q2. D apart. The force of repulsion between them is given in this way, K, Q1, Q2 by B square. Now I want, this is a constant, B is constant, K is constant. If I want the force to be maximum, if I want maximum force, that means the product of Q1 and Q2 has to be maximum. Yes, sir. So I want the product of Q1 and Q2 to be maximum. See, this is the basic concept. And if you are given any two numbers, how you arrange or how you can put one to the other, subtract one to the other so that the product is maximum. Do we have any idea? Yes, sir, this is quite simple. Suppose Q1 plus Q2 is constant. Means this has to be fixed. Now you can transfer from Q1 to Q2 so that a new thing formed. Let's say a new thing formed, that is Z, which is a product of say Q1 dash and Q2 dash. Q1 dash and Q2 dash. And what is Q1? Let us say I have transferred a small charge Q. I have transferred, say, I write the expression something like this. Q1 is equals to big Q1 minus Q, and Q2 dash is nothing but original Q to plus Q. See, this is the expression I am using, and I want to make the product as maximum. I want to make the product as maximum. Now how you make the product as maximum? Q1 minus Q, Q2 minus Q. Now do you have any idea what is the variable over here? So variable over here is what? So is Q. The variable over here is Q. How much you need to transfer? The variable over here is Q. So what we have learned in class 11. So See, very basic thing. The concept of maximum and minimum. If I say the concept of maximum and minimum, the first thing which strikes my mind is the concept of differentiation. When I use differentiation, we are actually going for some maximum value or some minimum value. Yeah. So how to put Z? Say Q1 into Q2, sir, minus Q1 plus Q2 plus you have Q square. This is the expression of Z. Now what to do? So dz by d of small q, which is the variable over here. This is the variable over here. This q1 and q2 is constant. This because this is the fix. This is 0 minus only q1 plus q2 and plus 2q. I hope so. This is clear. Now, what is that thing? What is that thing we need to do? Sir, please kindly check it over here. So, we know dz by dq, we need to equate it to 0. Yes, those who have done differentiation in class 11, they know what I am talking about. They know what I am talking about. So this is the amount of charge. This is the amount of charge which I need to what? This I need to take out from Q1 dash and put it to Q2 dash. Now check it. Is this thing correct? Sir, no sir, this is not correct. Why this is not correct? Because there was one minus and there one was plus. Everyone do the same mistake. There was one minus and in this case there was one plus. So check it out. This is one minus and this is plus. Both are not minus. I have put both minus. So one has to be plus. This is a small calculation mistake. See, this is minus, this is plus. Okay, I have transferred, not you are taking out minus q from both. You are taking out minus q from here and putting it over here. So over here this will change to what? Sir, see, check it out. It is minus q2. So it is minus and it becomes minus and it becomes plus. It becomes plus. So over here what we have? Q1 minus Q2 by 2, because over here it is plus Q. So this is the charge. We have to take it out from original Q1 and place it to Q2. So check it out what happens. So now Q1 dash will be equals to Q1 minus Q2 by 2 and Q2 dash will be Q2 plus Q1 minus Q2 by 2. If you solve this thing out, it will come out to be Q1 plus Q2 by 2 and it will be Q1 plus Q2 by 2. Sir, in practical, we need not to do the whole scenario. This is the first time I am doing it. That's why I am explaining it like this. In your school examination, you have to do it like this, but in your entrance examination you need not to do. You have to simple keep two things in mind. I have two charges. They must give a maximum force only when after summing up divide by 2. After summing up divide by 2. Simple thing. So after summation of the both charges divide by 2, they have to be equal magnitude. They have to be of equal magnitude. Then only they can exert maximum force on each other. Then only they can exert maximum force on each other. You should keep in mind. So just one thing, no differentiation required. Keep in mind Q1, Q2 given, whatever it is given, the final charges has to be the sum of both the charges divided by 2. In your school examination, you need to do the whole process. I hope so. This is clear. Okay. Now, this is a very popular question asked in NEET and JEE Mains. Okay. and in sometimes school examination also. Now, next topic. Now, so what is the next topic? Next topic we are talking about the same equilibrium condition we will be talking about now in a different way. Now, this is a quite important thing. We name it as concept plus. Why? Because this all things are literally critical. You have to have a clear understanding of this thing. First, 3 charges in a line. End charges are fixed. End charges are fixed. 3 charges in a line and end charges are fixed. See, first of all, take 2 positive charges equal in magnitude. Take 2 positive charges equal in magnitude and end charges must be fixed. Okay, so end charges must be fixed is say plus q and say plus q. Let's say they are separated by a distance d. Let's say they are separated by a distance d. Okay, clear. They are fixed. Yes, they are fixed. You have to assume they are fixed. Now my question. What are the scenarios we can come across in this thing? First, keep in between plus q and plus q. See, they are fixed in between plus q and plus q. If we place a positive plus q, if I place a positive plus q, means the arrangement looks something like this. Yes. D by 2. D by 2. Yeah. Then, yes, the net force on the plus q is equals to 0 and they are already fixed. See, they are already fixed. Then, plus q is in equilibrium. Then plus q is in equilibrium. Check it out. Plus q is in equilibrium. Now, what equilibrium? Next. What equilibrium? This is the question. Now, how to do this? This is important. Part 1. Part 1, what we'll be doing? We will be doing equilibrium along the line joining. See, 3 charges in a line. We are starting along the line. Now, take a very close look. I am doing over here. Displace plus q charge slightly by x along the line. Displace plus q charge but slightly by amount x along the line in any direction. Any direction. So new formation. So this becomes d plus x. This becomes d by 2 minus x. So yes, sir. Yes. Now, over here, if the distance between these two decreases, the force increases. So what force increases? The force of repulsion increases. If the distance between these two increases, the force of repulsion decreases. So right now, say the force experiencing is F1, the force experiencing is F2. Now logically we can say the mod of F1 is greater than mod of F2. Now that means this plus q charge will have the tendency to return back to its own position. Yes, the plus q charge will have the tendency to return back to its own position. So, plus q will have the tendency to return back to its own position. So what sort of equilibrium is this? This is termed as stable equilibrium. This is stable equilibrium for the plus q charge. This is the stable equilibrium of the plus q charge. I hope it is very clear with you. Okay? So please, this topic is damn important. Okay? I hope so. We are done. So I will keep this thing over here. I will rub this thing off. Now once we have done, let us find what is the F net. F net means it is F1 minus F2. Yeah, see? F1 minus F2. We have already stated the mod of F1 is greater than the mod of F2. So can you do it for us? Yeah. Say K big Q small q, it will be d by 2 minus x whole square minus K big Q small q d by 2 plus x whole square. So check it out. K big Q small q, take in common this. This is a very interesting thing. You have to understand. D by 2 whole square. Achha, let's do it. D by 4 minus x square. See, I have done something. See, it is a minus b, a plus b multiplied a square minus b square and the total whole square. And in the above, it is d plus x by 2 whole square minus d by 2 minus x whole square. So what we get? So we get something like this: K big Q small q d by 4 whole square minus x square, the whole square, and over here we have twice d by 2 into x plus twice d by 2 into x. Now this is complete. So cut it, yeah, we cut it. Twice dx, it's twice dx. Twice K big Q small q dx by d by 4 whole square minus x square and whole square. Now we come up with a beautiful conclusion. What's this? It says, okay, rub this thing off right now. It says, if x is small, if x is very small, if x is very small, then d by is very greater than x square, and hence it can be neglected. So F net has a new expression. F net has a new expression. 2k big Q small q d into x by d to the power 4 by 16. 1d cancels off. 32k q big Q x by d to the power cube. Now check it out. What it says? It says this was plus q, this was plus q, this was plus small q. Okay? This will move in this direction with a net force. Now this was the equilibrium position. If you have done the chapter of simple harmonic motion, yes, if you have done the chapter of simple harmonic motion, then this position is termed as the mean position. This position is termed as the main position. Over here, the charge was displaced slightly from the main position. The charge was displaced slightly from the main position, and it has a tendency to return back to its main position. The same charge has the tendency to return back to its main position. So, F net vectorially is 32k big Q small q d cube into x vector, and you put a negative sign. So this signifies this force is acting as what force? This force is acting as restoring force. Why I am talking about this is the restoring force? Because this is proportional to the displacement from the main position. This is proportional to the displacement from the main position. So we have seen F net is equals to m omega square x. I hope so you know this thing. So 32k big Q small q by d cube is equals to m omega square. Sir, what it signifies? What? That means it won't stop over here. This small plus q charge will do what? Will do SHM. About which position? About the mean position with omega as angular frequency. And what omega comes out to be 32k q small q by m d cube whole root over. And what is time period? 2 pi by omega. And the time period comes out to 2 pi by omega. Now in the examination, are we required to find the whole data? Sometimes they give to find the whole data, but many a times they will ask you if a positive charge is kept. In between the two positive extremes, and if it is displaced along the line, it will execute SHM. And see, this workout is not very clumsy, but you can do it. I have shown you, but if you practice, this will take a few minutes. Okay, this expression will take few minutes. Okay, so we will do the full recap right now. Okay, so this is a beautiful thing. Okay, two extreme positive charges. A positive charge is kept at the middle. If it is displaced along the line, it will execute SHM. First oscillation and then SHM. Considering the fact x has to be very, very small. Okay, so let's make a chart. So, what we have? What is the conclusion we have? Key two positive extreme fixed charges. Two positive extreme fixed charges. Okay, two positive extreme fixed charges. Plus q. Now a small q is placed at the middle. Small q is placed at the middle. Okay, fine. This is in equilibrium. Okay. If displaced slightly along the charges, if displaced slightly along the charges, what it will do? It will execute SHM. Now, if displaced by some good distance, means simple x is large, then also stable equilibrium, but not SHM. That means, yeah, it will be periodic motion but not SHM. It will be periodic motion but not SHM. Now, next part. What is the next part? So, plus Q. Over here, the small plus Q is placed at the middle. If plus Q is displaced, perpendicular to the line joining the charges. Now what it means, if plus Q is displaced perpendicular to the line joining the charges, means this way, sir, say by a very small distance x, then this will repel in this way, this will repel in this way. See, they will repel in such manner F, and the net force and the F net will be something like this. So once it is displaced from this position, does it have the tendency to come back? No, it is not having the tendency to come back to its own position. So plus Q will not return to its own position. Plus Q will not return to its own position once displaced. So this equilibrium is unstable equilibrium. So this becomes unstable equilibrium. So this is a beautiful thing. So what are those beautiful things? Two positive extremes and a positive small charge is kept at the middle. Now the two positive extremes has to be of equal value. These two positive extremes have to be of the equal value. Now this is beautiful concept. Now with the same concept, I will put a negative charge at the middle. Now, okay, so let us rub this thing. I hope so this is clear. Now, say minus Q is placed at the middle. Say minus Q is placed at the middle. Then what happens? So fine. Now, displace. First of all, it is in what? This is in equilibrium. Yes. Either you place a positive charge or you place a negative charge. It has to be, this is attracted by both the sides, so this is an equilibrium. Now displace minus Q along the line of the charges. Yes sir, let's do it. Let us displace. Okay, so logically let's do this thing. Plus q minus q plus q. See, the distance between them decreases and the distance between them increases. So the net force between them increases. So but over here, what is the force? So in this case, this is the force of attraction. And over here, this is F2. And mod of F1 is greater than the mod of F2. We know the same, yeah? Because the distance decreases and the distance increases. So will ever minus q will come back to its own position? No sir, minus q will go to this charge. So minus q will never return to its original position. The same thing happens with the students when they go out of school and when go to colleges. They never wants to come back to the schools. Okay, so it won't come back to its mean position. So what sort of equilibrium? This is unstable equilibrium. This is unstable equilibrium. Now we go on with the case of displacing the negative charge along the perpendicular direction. Now, when minus q is displaced slightly perpendicular to the line joining plus q. So have a check, this is very important. Plus q, this is d. Achha, let's take this thing as d. Let's take this thing as d. Just for our convenience. Now over here, this is negative charge. So this will be attracted and this will be attracted and this will be attracted, and the net force over here will be in the downward direction. See, this is F, and this becomes F net. If I say this is theta, F net becomes 2F cos theta. F net becomes 2F cos theta. Now this is d, this is x, and what it comes out to be? This is d plus x whole square. Sir, yes sir, no sir, no sir, what you are writing? So this is d square plus x square to the power half. Now we have to write the expression of the f net. So first 2, and what was f? See, f was k big Q small q by this square. This square signifies what? D square plus x square, half the whole square is normal thing. Now, and what is cos theta? Cos theta is this acts as a base, this acts as a hypotenuse. So x by root over of what? D square plus x square. So what is the expression? Twice k big Q small q x by d square plus x square to the power 3 by 2. Wow! So this is net force in this direction. So simple thing. Sir, what equilibrium is this? This is stable equilibrium. This is stable equilibrium. Now next question. Sir, ये भी क्या SHM जैसा है? Is it looking like SHM? I don't know. You have to check it out. Is it looking like SHM? We will check it out. So first of all, these are the most important points of this segment. Let's do the next part. Whether this is SHM or not. So here we go. Similarly, if x is very small, if x is very small, then what happens? Then d square is very greater than x square. Yes sir. F net comes out to be what? Approximated to be what? Twice k big Q small q x by c. It comes out to be d cube. Okay. And similarly, yes sir, this is proportional to x. Yes. So if you write vector, this will be vector and you put a negative sign. Okay, if you put a vector. So we know twice k big Q small q by d cube is same as m omega square. You get omega out of it, you get the time period and you get the frequency also. So over here, simple thing, why it happens, plus q extremes and these are fixed, you have to keep in mind, and this negative q is displaced along, then it will come back and it will execute SHM along the perpendicular bisector. So minus q will execute SHM along the perpendicular bisector. Minus q will execute SHM along the perpendicular bisector. So we have done all the cases. Now if anyone says, so what happens if we have the two negative extremes? Very simple. I am doing it. Now, okay. Now over here, sir. Now question is this, sir, अगर ये x बहुत ज़्यादा है तो क्या होगा? तो वो oscillation होगा, but SHM नहीं होगा. Then we can't reduce this format. So if another point, if x is large, if x is large, then it won't be SHM. It won't be SHM. It will only be oscillation. Now, इसके बाद वाला जो topic, that is the most important thing which we need to know. Just we need to know this thing. Now, this I hope it is clear. This is bit complex, I know. Please keep in mind this expression. This expression is very important. This expression is very important. 2kqx d square plus x square to the power 3 by 2, where I have taken d. Please. Okay? So let's move on. Now, so here we are with the things, gist thing. Achha, let's do the minus q. If I place a plus q, what happens? Plus q will be SHM along what? Perpendicular bisector. Check it out. Perpendicular bisector will be SHM and it will be unstable along the line. I hope so this is clear. Okay, if I put a plus q and if I put a minus q, means both are minus, and if you are putting a minus, then it will be SHM along the line for small x. Small x means for small displacement, and it will be unstable perpendicular bisector. Which combination? Minus q, and in between it is minus q. minus q extremes, minus q middle. We have all possible configurations. We have all possible configurations. Now I tell you to do a homework. If I say this is plus q plus 9q minus q plus 9q minus q, and for this say they are fixed. They are fixed. So what I need to play, where I need to place a charge for the equilibrium? Where I need to place a charge for the equilibrium? So over here, very logical over here. Say something, sir. If I say, sir, if you place it over here also, definitely it will equilibrium. Yeah, I know. Then I know if I place any charge over here, since they are fixed. If I say they are